Hi, I'm Esther.
And I'm Sean.
I write about AI news here at TechTarget in Massachusetts.
And I edit Esther's stories.
We're here to talk with tech experts about everything AI and ChatGPT.
Don't forget Google Gemini.
Whether it's who's ahead in the generative AI race, the metaverse, digital twins, or even the latest in autonomous vehicles, we've got it covered. Right, Sean?
Yep, we've got it covered.
Hello, everyone. Welcome back to another Targeting AI episode. Today, we are talking to Luca Antiga, Chief Technology Officer at Lightning AI. Luca is not only a technologist, but he has a PhD in bioengineering and has previously worked in research. Thank you for joining us on the Targeting AI podcast, Luca.
Thank you. Thanks a lot.
So I wanted you to just kick off for you to start by just describing Lightning AI and what that is all about.
Yeah, Lightning AI was born out of PyTorch Lightning. It was created by William Falcon a few years ago. It's one of the leading frameworks for training models. Many models have been trained using PyTorch Lightning. One of them is very famous is Stable Diffusion, but many companies use it. We had 90 million downloads historically. We're about like over 5.5 million downloads a month. So it's really something that enabled a lot of researchers and companies to get productive and lower the barriers to train models large and small. It kind of streamlines all the things you need to know that are engineering related that enlarge the surface area for making mistakes, where you can make mistakes and leave performance on the table. And it takes some of these away from you so you can focus on the research, focus on developing your model or your data, and then you can scale up with some engineering expertise that you can put in if you know about it, or can delegate to the Lightning trainer. And so it's a way to lower the barrier and make you faster in general. And this is not unlike what Lightning Studios do, which we just launched. Lightning Studios are a way of using cloud computing at scale for building AI in a way that really feels like your laptop. So, traditionally cloud platforms, when you landed them, you're exposed to many intricacies of using, cloud computing resources, permissions, and how you set up your data, how you move your data, how you configure your environments, and so on. And so it takes a whole half-time job to learn how to do that as a machine learning practitioner or startup builder or builder in general. So the number of things you need to keep in your head, so the cognitive overhead increases a lot, but also the surface area for mistakes increases a lot. And what Lightning Studios do is provide a way to take a lot of that away. So if you can use your laptop, you can use Lightning AI, and if you use Lightning AI, you will have access to compute resources that can go from CPU machine, and then you go to a GPU machine, but the environment, the studio, stays the same. So your editor, your user interface, your data stay there, but the hardware in the back is kind of switched to a more powerful hardware. Or then you can duplicate your whole environment, including checkpoints, data, and so on, and run it across like tens of machines or hundreds of machines, right? And so getting access to that kind of thing feels very natural and smooth. And so the end result is that your velocity is maximized because you don't need to think about certain things. If your velocity is maximized, you have a chance to keep up with whatever is happening in AI today. Otherwise, if everything comes with a lot of friction and it takes an organization weeks to months to set things up in a certain way, then everything changes. And then you need to jump on something else, and you cannot possibly keep up. And it's also a way for the community to share their own environments and their own studios, so that we can, it's not just code, it's like how you configure your environment, your dependencies, your checkpoints. And you're basically parachuted into this pre-built environment that somebody created and published and shared with you. So you can maximize the time it takes for you to take that thing, make it run on your case, and maybe produce something that you can share again.
Okay, so Luca, is it correct that you're just one of the developers behind PyTorch Lightning, or is your main role, your company is to provide commercial support for PyTorch Lightning? Like, where do you fit into the community of PyTorch Lightning, the open source
So
framework?
PyTorch Lightning, we are the creators of PyTorch Lightning. We don't sell support. What we sell is Lightning Studios. So your ability to run on the cloud, and soon also not on the cloud. So to use compute in the most streamlined way possible. Whether you're using PyTorch Lightning, if you use PyTorch Lightning on Lightning Studios, that is a magical experience because you don't change your code. You can scale from 0 to multi-machine and train your own LLM if you want. But you're not forced to do that. You can use any framework you want in Lightning Studios. PyTorch Lightning is a fundamental building block of a vertical stack that we're creating that is aimed at maximizing your productivity when building AI and sharing your organization or community.
So, what particular problem were you looking to solve when you did create PyTorch Lightning?
Really, it was born out of a need for William to be more productive himself in the environments he was working at. He was at FAIR, the Facebook AI Research Lab here in New York, and NYU, and he had access to all this like machines and so on. And he wanted to run across machines, many experiments at scale, at a time when uh, it wasn't very common because not a lot of people had this ability or opportunity to run across machines. But as soon as you did, then you would like get into the hurdles of doing that. And so what he wanted to do is like do it well once and then reuse it across his experiments. And this is how PyTorch Lightning came to be. And it was very then once he started sharing it within the organizations, it was very driven by the need of other people to be successful in making it easier to collaborate, making it easier to scale their workloads and so on. And he caught up really quickly.
Can you talk a little bit about just the whole movement toward open source models in generative AI? I mean, we have Lit-Llama 2. So why is open source important, and how can enterprises best use open source to develop and implement their own models?
Yeah. So when we talk about open source, like the question of what exactly is open source in generative AI is still a bit open in the sense that you have code that is open source to create those models, and then you have weights that you can use. They're licensed for you to use as well as you want, right? One aspect of open source that is coming out right now is open source has always been great because it put things together. Like, from A, somebody develops A, somebody develops B, and now you can create A plus B, which equals C, and you can share it and so on. This is the mechanism. Up until recently, we haven't seen this mechanism, right? We've seen people taking code and then large organizations like Meta training Llama or Mistral, which is not large, but it has large compute, um, uh, train a model and then put it for people to use it. And then the community would fine tune those models and so on different data sets and made them do different things. Right now, what's coming up is the ability for models to be merged together. And so I have a model A and a model B, and now with model merging or different kind of composition, you can create something C that kind of puts the two pieces of knowledge together. We're not still there yet, but that's a signal that I think the future will be made of like maybe a few larger models and quite a few smaller models that are not so expensive to train, that a community can put together to obtain something that is greater than the sum of its parts. And but going back to your question, so I think like the question of what open source is and how the mechanisms that fueled open source until now will fuel AI are not completely developed yet. They're coming up right now, I think. But in terms of companies, I mean, it's pretty clear that on one side, we have very capable closed source model and then a few other models that you can use with some of them with certain limitations for use, and some of them without those limitations, so you can do whatever. And talking to many customers, it's pretty clear that the ideal would be to kind of be able to run models without sending your data to anyone. Of course, it goes without saying something that you want to do. Of course, at the same time, there are many things that these companies are doing behind the scenes, like better red teaming, or when you develop an application, you build a nice UI around it. In the generative AI world, a nice UI means you aligned your model to behave in a certain way, right? So that it will not just hallucinate too much, or it will actually be nice to you. And this alignment process is something that a lot of large companies are doing in a very in a way that kind of grows with their own internal experience that they're not necessarily sharing outside. And so it's kind of apparent that if you use like GPT-4 or ChatGPT or Anthropic Claude and so on, you get a certain experience that is well-rounded from a conversation compared to other open source alternatives. What is happening right now is that open source models are getting better and better because there's a lot of people that are working on them. And so on one side, companies can start by using external APIs, but more and more companies are saying, okay, but this model is good enough for me because I had somebody like creating a POC for me. And, in my process of understanding how my company can leverage GenAI to do something useful, I can recognize that this open source model is good enough. Like it can do what I need. And so I think there's really a need, and this is one of the reasons why we created studios. There's a need for platforms that make you very nimble. Like they're open, they give you access to a number of resources that can help you create the end-to-end experience from the idea to the value that you can extract from AI, using a mixture of closed source and open source. Honestly, I think like this composition that I was mentioning before will make it necessarily very hard for closed source models to necessarily keep up. I don't think that open source will outperform closed source, will outperform directly necessarily. Open source will tend to keep model size low with and more capable, which is really enabling and really groundbreaking. And closed source was trying to win out by scaling out, probably, right? And it's a very nice race, I think.
It's interesting that you describe it as a race, and I like what you spoke about, that we don't have that in the beginning. You're talking about we don't have all the components that we need for open source yet, right? And so when I speak to like analysts, or I speak to just people in general, they speak about like yes, there is this movement towards more open source, and I like that you're like, oh, there's this combination of open and closed. So it seems like you're saying that we need both together. I wonder how we can deal with some of the challenges of open source that I've heard, which is like, obviously there's not a lot of support compared to closed source, where you have the support of the company that created it.
Yeah, I mean, support is needs to be qualified, of course. One challenge that I've heard from people building their system on top of closed source is that closed source can change. So you build something on top of something that you don't have access to, and then that something kind of evolves in time. And the way you tuned your system to use that other thing may not work next week because somebody at that company decided to kind of pull the rug a little bit from under your feet, and for good reasons, right? Because maybe there was a safety issue, so they had to patch that, and now your system is reacting differently. Which you can argue, yeah, with a open source model you fully control, you can decide when this happens, right? maybe it's harder for you as a person who is using open source, as your organization, if you don't have the right tools, it would be harder for you to recognize that there's a safety problem, for example, because some of the work these open source closed source companies are doing is like the red team, right? Trying to understand and from all their users where problems might be and correct them and so on. And with an open source model, you have an artifact that is there, and it's up to you to manage this process. So if I had a lot of stake in a product that is based off something that somebody else is managing, I would want to have full guarantees that things won't change overnight. And I don't think we're still there in terms of offering. At the same time, if I were to adopt an open source model, I would want to have all the processes in place to ensure that I have metrics to look at that tell me if something is wrong with whatever open source model I put in production. And this is why I think point solutions are hard today. Like if I have something that serves my model at maximum speed, that's great, but that doesn't solve the problem of creating value with AI. Of course, it's also a piece of that problem, but you need to have a lot of pieces there that you can use to understand what's going on. Some observability, some metrics that tell you whether you can trust certain outputs or whether you should block certain inputs and so on. Ultimately, it's very hard if you are so reliant on a model for your operations to completely delegate this to third parties. Like even if I use a closed source model, I would still have to implement those things, right? Because of course, OpenAI, for example, is trying to make it work for all their users. But my business needs certain things to be put in place. So a part of this, like making sure that your model is focused on the problem that you're trying to solve and it has good performance there, is still up to you, even if you use closed source model. Having the tools that allow you to put together all these different facets into an end-to-end value creating workflow is really, really important right now. And we need to have companies come in and reason about these things and try things out and converge on something that works for them. And it's like, there's no way around it. Of course, you can base yourself off integrators and companies that do that as their own core business to enable AI in certain places. But at some point of the chain, like having one API endpoint that serves one model is not going to solve your problem of integrating AI in your business in a safe, secure way. You need many pieces. This is what we like to think, that we have a platform that enables you to do that without like spending too much time on thinking about how to make these things happen infrastructurally.
I was going to ask, you mentioned like, obviously, it's kind of hard when people are trying to move things from one thing to another. But I find that just generally speaking about humans here, we're very consistent. So we don't like change, obviously. So in terms of like, there are people who are straight up just AWS shop. There are people who are just straight up Google shop, right? So for those people, does it even matter if you're already a closed shop if they move, because they're like, well, it's just we'll just relearn. For enterprises who are strictly one shop, right, doesn't matter whether or not like there's a movement within their closed source, right, or whether they change it to build something else, because you say, a lot of the issue with closed source is the fact that sometimes they can change easily, right?
It changes behind your control. What I meant is that today, GPT 3.5 is responding in a certain way. Tomorrow, it may be responding in a way that is not exactly the same, or not the same vibe, because it's never exactly the same. But it may behave differently to certain stimuli. And that is beyond your control, right? So even if you're an AWS shop, things may evolve in a way that kind of need to prepare yourself for, because certain API endpoints will start responding differently at some point in the future. So this is one of the risks that as a business I need to understand. Like, how am I gonna deal with change that is not under my control, which is basically the whole risk management problem, right? So if you have an API that gives you the price of bananas, you know that API will never change, will give me the price of banana. But now it's giving me the price of bananas and apples, right? Averaged, right? Which is a different kind of information. So, and this may happen without even me knowing. Because unfortunately, if I'm talking about bananas and apples, it's clear cut. If I'm talking about how a complex language model will react to certain stimuli, it's like saying, is this cat the same cat from yesterday or not? Did they give me another cat? Like, it's not so easy to assess if something changed. You may see a degradation in certain performance if you measure that, but it's not that clear cut. Even evaluating models right now, it's an open problem. You know, they may perform well in some benchmarks, maybe reasoning benchmarks, but not that well in a symbolic task that you may think it's simple. So it's part of the value they have. They are so multifaceted that governing the risk associated with language models in production is still an open-ended problem. So if something changes, even subtly, on another side, and I don't control that, then I need to factor that in as a risk.
Okay, Luca, you talked about support a little and safety. What about other challenges like privacy and security with open source?
When you talk about privacy, if I deploy my model within my infrastructure, then of course I'm gonna not send my data anywhere, and the model is just running within my closed environment. Of course, from a security standpoint, if I then, I don't know, fine tune a model using data from my customers, and then I expose that through an API, and then somebody forges an attack with prompts that will exfiltrate this information outside. This is something that can happen. It can even happen with closed source models, because there have been attacks on APIs where by setting a certain prompt, I can potentially get information that is not necessarily for external consumption that the model was trained on. And this is kind of common. This is one of the challenges of models. So it doesn't change between open source or closed source. But of course, if I self-serve something, then I'm going to be responsible for it. And so I need to have the right tools to assess what risk I'm encountering. But again, privacy per se is something I need to design for. When I'm training a model, I'm not going to want to expose it to data that is too sensitive, because I know that eventually, if that thing is going to be an API, then it may exfiltrate data. But if it's for internal use within my organization, then having an open source model that serves even private data that is like for consumption within the organization, that's going to be totally fine, right? So whereas sending the data to a third party for me to have it served back, then of course I need to trust that third party that will not use that data for other means. So as usual in this cases, there's no like bullets, but the situation is like risk management at large, right? I need to know where threats might come from, and I need to mitigate them as much as possible. And it's very application dependent. Like I'm seeing a lot of uses for internal consumption within organizations for language models, even before I see products being pushed out that have language models. There are so many things in companies and organizations that can be optimized, so many processes that a lot of people that before had only the control find as a tool in their Word documents, for example, or in their knowledge bases, now they have much richer ways of sifting through internal documentations and so on. And there's so much to build there. And that thing is relatively low risk.
Last year, when Meta released Llama, Lightning introduced Lit-Llama. So what is Lit-Llama, and why is there a need for something like it? I saw the blog post you wrote a little bit about it.
Yeah. Well, when Llama landed, it was kind of a revolution, although many other models existed before. But Llama showed us that if you keep training, then the performance of the model can go up considerably for a compute budget that is not so, it's not so great, not so large. It made those kind of models in those ranges of parameters, on those ranges of many tokens, the words that they were trained on. It made people realize that there was a lot the community to do around these models, and it was not just something that could happen in organizations with crazy amounts of compute. Although Llama itself was trained on massive amounts of compute, but necessarily, if things are open, if they are hackable, they will tend to be more and more hackable. And this is a tendency that every system had in the past, and this is not the AI is not it doesn't exclude that. I was mentioning model merging as something we'll see more and more of, like I have model B, model C, and put them together, fine. And with little to no compute, I actually create a new model. And so Lit-Llama, so when we saw the Llama implementation, there was no training code for that. It was only inference, and it was also licensed with a license that was hard to use in companies. And so we said, okay, let's take NanoGPT by Indiresh Chapati that we work with a little bit with the code base. I mean, I sent a couple of very small PRs to that, but we were kind of liking the fact that it was so hackable. It was minimal, hackable, and understandable, as opposed to other frameworks that they were a bit harder to work with because they had many layers of complexity that you had to sift into. And so we said, okay, let's take NanoGPT, which was like a GPT implementation, minimal GPT implementation, and let's turn it into Llama, the model architecture, which is very close to a GPT model, and publish it under a very liberal license. And I took great care of making sure that I was not copying anything from the code base that Meta published, so that the new code wouldn't be subjected to the GPL license, which is a viral license and it's hard to use in companies. And so that's what Lit-Llama was. Nowadays, there are many minimal implementations. Meta itself published a few repositories with minimal implementations of models. And the principle is, you need to make things hackable. Again, to the point that we were saying before, the moment it's hackable is the moment people can build on top of it. And hackable means avoid unnecessarily complexity in code and make it one file understandable if it's possible, of course. Certain systems cannot be made minimal necessarily, but these systems are. And so they should be as minimal as they get. And then, so Lit-Llama was a way for us to give to the community something that they could look and fully understand what the how training and fine-tuning worked and so on. And now, there are many implementations, minimal implementations. Right now, we're focused on improving the journey of the community and customers that want to use compose small models, use small models end-to-end to create full products, internal products or experiences, in particular on top of studios, of course. And Lit-Llama and Lit-GPT, which stemmed off Lit-Llama as an extension to not just support Llama, but also other models, and it supports many architectures right now, is our way to have something we can work with ourselves, and the community benefits from this. So the need, I think, to respond to your point about why is it something important, which is a code base. It's not a model itself. It's a code base you can use to create models. Like Tiny Llama was trained on Lit-Llama, on Lit-GPT. And Tiny Llama is a 1.1 billion parameter model, which is small, and others have been training with that code base, is to maximize the minimize the complexity, maximize the hackability, so that you can turn whatever it is and turn it into something that is useful for you. Of course, it comes with trade-offs, and you need to understand. And so now we're trying to make it simpler for people who don't want to understand. It's simple to understand if you want to, but it needs to be simple to use if you don't want to understand. So now we're kind of adding a few high-level layers that are really, I think, they're important, because right now it's not just like pre-training, it's not just fine-tuning, but it is like how you do end-to-end stuff, right? How you build a system that automatically optimizes prompts and so on. There are many great projects about that right now. And we would like GPT and Lit-Llama to be some of the building blocks behind.
Okay, so turning to developers, now that your platform has become pretty popular among AI developers, what are the biggest, the most pressing challenges facing AI developers right now?
Well, I think, the challenges are a bit like in many directions. Right now, it's still very hard. And I think we have a solution with Lightning Studio to build on other people's work. You see a lot of people kind of patching things together, trying to run on Colab, Google Colab, or publishing a Git repository and then having the problem how to configure it and where to run it and so on. So it's still very or you buy a machine and you keep it under your desk, and that's where you do everything, and you configure it the way you want, but it's not something that you replicate. So I think it's for the community, it's still very hard to have these mechanisms by which I say, oh, nice, Esther, you did that thing. Now I would like to augment it a little bit. Like, let me put this thing that you did with what you Sean did to create something else. And there's still a lot of hurdles in doing that and share things and so on. There are some mechanisms to share, like models, checkpoints, and so on. But it's still very hard in general to build systems that I can replicate and work with. And I think like Lightning Studio right now is the way I see it happening. And there will be others in the future, but right now I think that's a phenomenal mechanism. And we're gonna kind of open up the possibility for people to publish their own stuff. Right now, like, it's not fully out there. You can publish if you come in contact with us, but it's just a rollout thing that we are doing this month. But once that's fully out, I really hope that this will improve the velocity of how knowledge spreads across the community.
So, generative AI, obviously, you've kind of mentioned it a little bit. How is that changing the landscape for developers? Has it changed it at all?
Oh, wow. GenAI is changing the landscape, because, if you go back 1 year ago when ChatGPT was released, I think the general vibe was, software development is, now will be automated, blah, blah, blah. It's never like that. It takes, time. It takes years to get there. But being a software engineer today with no exposure to generative AI, as a building blocks of building systems, it's going to be harder and harder. At the beginning, it started a bit as a gimmick, right? And to use in isolation. Of course, it can help you code, but sometimes yes, sometimes a bit less. Like, it's quite common to have an interaction with ChatGPT where you say, okay, how do I do this? And they write something. They say, no, that's not quite right. Oh, yeah, I apologize. You should do this and that instead, blah, blah, blah. And it takes a few iterations. But the point is not like productivity per se. Yes, sure, it's a coding assistant, and I think it's great for that. It can get you unblocked. But as a software engineer, knowledge on how I can build a piece of my system using a generative AI tool, like a model, and maybe a way to automatically optimize the use of a model, or manually through prompting or whatever, so that there's a part of my system that is driven that has some complex behavior that I don't have to hand code, but it's kind of managed by a generative AI model. That is the thing that gives you superpower. Just not creating a chatbot that is there in isolation, but it's creating a system that you can have a chat with, interaction with, that has abilities that are specific to what you need to accomplish, and have that as a part of a bigger system. Then that's going to be the thing that distinguishes moving the needle in the in the development space from trying things out and see if they stick. And so as a software engineer, I think there's some hype, but there's a lot of thinking that needs to go beyond behind how do I use this as a building block of a bigger system.
Okay, Luca, as someone who I assume works with developers as a software engineer, how have you? I don't know if you've been following the New York Times lawsuit against OpenAI or other lawsuits involving intellectual property and data property rights.
Yep.
So, how does Lightning AI approach that data property with studios and other platforms?
Yeah. So our platform makes it really easy to create an organization and work in teams where the data stays within your own, even within your own cloud infrastructure. So we have a modality that is fully managed, where you go in the platform and you can load data in the platform, or attach data lake way, attach sources of data where you have that. There's also a modality in which you can run fully on your own cloud account. So all the compute and data happen within your own virtual private cloud, and we only orchestrate that. So I would say that we maximize our ability to keep data safe and within the confines of your own process for data privacy. Of course, the lawsuits apply to something else, which is I use some data to train, and I shouldn't have used it to train a model, and now the knowledge is embedded in the model, and now the model, I cannot evict it from the model, or easily evict it from the model. And so what do we do? And I think the response there is that if you have the ability to start from models that you kind of vetted with your legal, that what was the training data from, and you can somehow ensure that the training data was something that was okay for you to train on. And then if you have data from your customers that you use to train a smaller model on and put it together with the previous one, or continue the training of the model you start from, the base model, and augment it with new knowledge, all these processes are well supported. We kind of optimize for this process on our platform. Then, of course, it's up to the organization to expose the right data outside. So our goal is to enable organizations to handle the process end to end, so that they can be owning the process of doing the right thing with data, and not necessarily rely on other people's judgment on this. So that's we from this point of view, we come from an angle of, as an organization, you should be able to build a model that, from IP and intellectual property rights, is fully okay for your organization to, and it's not of course, one size doesn't fit all. People getting close to it, and we are talking to a lot of customers, of course, and they all have their own goals, and our goal is to enable them to manage all this process by themselves, and make them their own decisions, and have no gray areas in this process. So we're enablers rather than having our own position in it.
Very interesting. So it seems like you're leaving it to the customer, right? You're not necessarily saying all data on the internet is fair data to train on.
But we're giving you the tools. Like, for example, we just published a studio with which you can prepare data to train on 3 trillion tokens, which will let you train a model that is equivalent to a Llama model. Then we can discuss what kind of data you use and so on. If you want, you can. We have tools to scrape data from sources that you consider as your organization okay to take data from. And then we have tools that enable to convert that to a data set that you can use. And then we have studios to take that data and run the whole pre-training. And we've done it for Tiny Llama. We've reproduced the full training on 3 trillion tokens. And we know that it's going to behave correctly, and we know it's going to do where you want. And so as an organization now, your gap between not being able to own that process and being able to actually own that process, make the decision that makes sense for you, that gap we're bridging. And so now it's up to you to understand like what is right for where you want to go with your org. We smoothen that path to get there. We make it possible for you, even if you're not OpenAI, to do that, right? Or a researcher at some top level laboratory, to actually do it within your org. Now, the problem is for you. Like, now you need to make decisions. What data do I use? Do I use books, for example? I don't have rights to use and I don't own. I don't have license to. Or do I use data sources that I'm licensed to use? That's a question that is for each organization to solve. What we're doing is taking away all the other things, like we were saying with PyTorch Lightning at the beginning, right? There's a lot of engineering to do, but we can take that away so that you can focus on the problem. And the problems should be, yes, we want to train a model on certain data. What can we possibly use that is good for us to use and that is right for us to use, so that we then can build a business around it or augment our business. And you need to own all these decisions. And in order to own these decisions, you need to take away all the technical hurdles. Otherwise, even before you get to this decision, you have like a mountain to go on top of, because you need to solve so many technical problems that you might even overlook the real problems, which is what data do I use, what can I use, and so on, which are the actual like fundamental things that will make a difference for your business.
Okay, going back quickly to smaller models versus super large models like GPT, Claude, Mistral, whatever. Do you think that they'll continue on parallel tracks, like proliferation of smaller, safer models, more customized, while the big ones keep getting bigger? Or do you think the smaller ones will start to chip away the big ones, and the enterprises will go toward smaller models?
Well, I think it will be like, just like software, there will be a good mixture of both. One of the ways closed source companies can make their products good in terms of like APIs and models is making them smarter, making them more curated. So improving the UI, their UI, not UI as in like the chat window, of course, but the way the model reacts to stimuli, and improve the safety and so on. If that's done through scaling to larger, then they will scale to larger up to a point where it makes sense for them to run the operation, not lose too much money in the process. So for sure, closed source will go. I mean, I see it going in these two directions. And of course, integrations, like one of other ways that companies have to like make you use them and not other things is like, how well can you integrate with your text editor or your folders on your computer, for example. At the same time, I believe I see a lot of signals that the way we're training models right now is pretty wasteful in terms of like how much data is needed and how many parameters are needed. And there are indications that many of these parameters are actually not very useful in practice. So you can reduce them without losing the quality, or even improving the quality by taking away something that generates noise within the model. I think in 2024, we'll see smaller models become more and more capable. So now then the question is, and use less data to be trained to become smart, and use self-reflection, self-improvement to become smarter and smarter. So if that's the case, how good is good enough is a question. Like if you strive for AGI, whatever that means, then it's an open-ended thing. But if you have a business, you want to put some models in production because you want to solve the problem, you come to a point where you can actually generate value out of something that is small, and it's better for you because you control it and stuff. Like we've said previously. So that may be in conjunction with something very, very, very smart. It's going to be the solution. I don't see particular friction between the two movements, let's say. It's pretty clear that the community will go towards smaller and in combination. It's a Darwinian process, right? More people will do more if they can compute with less, right? So if they have the tool to become creative and to unleash their creativity, then they will use it. If it takes a lab from a top-ranking university, then fewer people will be able to use their creativity to improve things. But I see the signals of this happening in the wild right now. So the capability of smaller models will go up to a point where smaller models will be pretty good already to do a bunch of things that create value for companies. And so that will not sunset the bigger models because they will use for different things, like for more human-like interaction, more complex stuff, or to kind of get the smaller model up to speed. But sometimes there are limitations in the purpose of services for larger models to be used to improve smaller ones. But that already tells us that there's this like very beneficial friction between the two tendencies.
So we're running out of time. So just to wrap up, obviously everyone has to be concerned about regulation. And so I wanted to just know, what's your take on regulation? Do you think that the generative AI space market isn't moving too fast, or are you just like, we'll see as it goes?
No, I mean, moving fast is a good thing, and I think regulation. I come from a biomedical background, and regulation there has been with medical devices there for a long time, and nobody has ever regulated a technology in itself unless it's really, special. And then we can debate whether AI is special enough to be regulated in the abstract, like for viruses or nuclear weapons. But then the application of certain things to certain things is regulated, right? So when you bring plastic is like, regulated because it's plastic. When you make a catheter, you need to insert in a human, then that's when that particular application of that kind of plastic gets regulated. And so I think that like regulation is good when it talks about the application scenario. Now, I was mentioning, is AI at the same level of something that has a destructive potential? That you can compare it with a virus in a lab. I don't think we're there yet, and I'm not seeing how this can become true in the foreseeable future. And trying to curb this will create, like, for sure, ways to advantage a subset of actors, and will prevent the majority of the people that can bring a meaningful contribution also to understand how to manage this technology properly and how to make them more secure. So I don't see a net win in regulating the technology per se, right? As usual, the wrong technology is usually a good technology in the hands of the wrong people. So that's what we should actually be more attentive to, rather than the maths itself.
Well, thank you so much, Luca. This has been so interesting. I love what you have to say about open source. So thank you so much for your time.
Grazie.
Thank you for having me.
Grazie tanto.
Grazie a voi.
To our listeners, thank you for listening in to this episode. Please feel free to leave a review and just keep tuning in. We'll see you next time on the Targeting AI podcast.